Uh, Yeah, Sresht, no, Sresht.
Yeah,
How are you all?
I'm good.
1 second, Amma. Uh, I'm just sending out a reminder. Let me quickly check. Uh, okay, give me a minute. Nisha, Fahima. Let me quickly check. Okay. How are you guys? How was the break?
It was
Oh, good. Okay. Did you get a hang of similar triangles?
yeah,
Was the homework relatively easy? Hey, Sresht, I really want you on the video. I cannot permit you to attend the class without video as well, right, Amma?
yeah, I didn't see it.
Yeah. Take your time, but come on the video.
Yeah,
Okay, did you get a hang of similar triangles, Vishrank?
Yeah, I got the
Homework was a little easier, right?
Yeah, it was easier this time.
Okay, I reduced the pace. Okay, but I think now that we know what are similar triangles, we'll try to go ahead and solve some problems. Does it sound good? Okay. 1 minute. Mhm. Okay. So you know how to prove triangles are similar now, correct? Okay. So now we'll solve for 4 or 5 problems in similar triangles, and I wanted to give you some insight on finding areas of complex shape, which isn't a difficult topic, and any one of you in this group can solve if such a problem comes in AMC8. That we'll do 2, 3 problems, and I'll switch to permutations. Okay. Seriously, if we can finish some 8 to 10 problems and permutations today, after going over the concept, I'll go to combinations next week. Does that sound like a plan? You all understand what we are going to do? So for today, we'll work on, now that you know the basics of similar triangles, right? You don't know everything, I know. Okay. Last week I had difficult time. I did see that meaning there was some issue with the concept related to how to prove similarity. What is similarity? Now we know that. We'll go ahead and do 4 or 5 problems on similar triangles. Then we'll also do 2 or 3 problems on area of complex shapes. After that, I plan to move to permutations. Okay. We are able to get through 5, 6 problems. I'll make my home, meaning I have not set the homework for today because based on how the class goes, I'm going to make some modifications. So I seriously intend to give on similar triangles. Then what? Area of complex shapes. And then we can move to permutation. Next week, if possible, we can do combinations. In the meantime, as a part of whatever you're finding or researching, right, try to get into Pascal's triangle. What is Pascal's triangle? What is it used for? How did Pascal come up with the triangle? Note it down. Pascal's triangle is something I want you to research in Google or go to ChatGPT. Learn a lot about Pascal's triangle and come back. Make sense? My main intention for you to give this is what are the practical applications you can use Pascal's triangle. Okay, that'll be useful next week because I'm not going to go into combinations today. Any questions on that? Okay. Let me see. Oh, I didn't save this at all. Okay, let's see. Okay, now just give me a minute. Okay. Oof. But I want similar triangles. How many of you know 3D geometry well? Do you all know 3D geometry well? That is a question I had for you. Do you all know 3D geometry well, Amma? Meaning you can shout out whatever you know. Have you solved problems in 3D geometry? Tanishka, how about you?
No, I don't think so.
3D geometry means what I'm asking. Let me tell you what I'm asking first. Um, area area of a cone, surface area of a cone, volume of a cone, volume of a cylinder. Have you done that?
I know most volumes, but I don't know all of surface areas.
Yeah, I
Nice.
know like a little bit of volumes too.
You know a little bit of it. Okay, that has not come through your school yet.
It probably has, but I don't know.
Okay, see, that is one part in geometry which I have not touched. I may not go there. First, let's do all of this, then go to permutation combination, which is quite important a topic. I'm trying to cover the major ones that you'll get problems in. 3D geometry you can get, but whatever 3D geometry problems you are going to get, it'll be easy, provided you finish the base, school-based geometry for 3D geometry. If you can finish, then those problems will be easy, is my honest thought about it, okay? Whereas for algebra and all, school-based algebra is not enough. Let's see. Let's see. Let me go over to one problem in similar triangles. You're able to see my board?
Yeah.
Okay, cool. How about this? Can we try this one? How about this? I have. Oh my God. Okay. You want to do, or you want to try, meaning it's just that first of all, we should be able to chart out the diagram. Will you be able to try? Or one of you can draw it on the board as well. Would you be able to draw, Ma? Otherwise, I can draw. Well, let's do it a little faster than last week. Can I draw? Or one of you can draw on the board as well. Whoever would like to try. So these are all based on similar triangles. A, B, C, A, B, C, BC equal to 5, CA equal to 13, AB equal to 12.
Isn't this a right triangle? Because 5, 12, and 13 are right triangle.
I really like it. Yes, it is a right triangle. I really wished somebody would say that. Yes, it is a right triangle. Why did you say it's a right triangle?
Because 5, 12, and 13 are triplets.
Pythagorean triplets. Good job. So can I change the figure? Very nice, guys. Observing this is very good, actually. 12. Now, E and F are chosen on sides AC and AB. AC and AB. Okay. Chosen. E and F are chosen on AC and AB such that EF is parallel to BC. So basically, I can do it like this. Parallel means see the marking. Now, given that triangle AEF and trapezoid EFBC have the same perimeter, find the length of EF. Any thoughts? Any thoughts? Guys, you have to think and keep me, meaning even if it is wrong, right? Let's together think. You want to think? Am I recording? Mitra wanted me to record and she's here. Yes. Okay. Any thoughts, guys? I'm open to whatever you say, but I want you to say something.
Yeah, the AEF, triangle AEF and triangle ABC are similar triangles. So
AEF is similar to Sresht. One correction, Sresht. AEF means what is a bigger triangle? Same order you have to say. Is similar to triangle?
ABC or AECB. ACB.
Ah, that's right. ACB. Good job. So ACB. Now, when they are similar, what can you tell about the sides?
The sides are proportional.
Exactly. Sides are proportional. If they are proportional, what can you tell? Meaning, how can you define? Meaning, I have the sides of ACB. I don't know the sides of AEF. But what can I say about it? If this is 5, what can this be?
X.
Yes, but I should be able to relate all the 3 sides. Then only I can find the perimeter, right?
Yeah.
So you all know when the sides are similar, when the triangles are similar, sides are proportional. What does it mean? Proportional means there is always a scale factor, right? Can I have the scale factor as x? Can I take it as 5x?
Yeah.
The x can be a fraction or it can be a
Greater.
fraction less than 1 or it can be a number greater than 1. It doesn't matter. Here, the x value, what do you think the x value can be?
A fraction.
Yep, here it's going to be a fraction. Good job. Sresh, you did a lot of work during the holidays.
Yeah.
Looks like it. Good. Very nice. Okay. Now, if this is 12, um, okay, I'm sorry, what can this be? You tell me, guys. Meaning, I'll put it in a different color so we are clear with. If this is 12, what can this be? See, the scale factor is the same whatsoever on all the
12x.
sides. What is it?
12x.
Yes. How about the other?
13x.
13x. Yes. Tanish, 13x. Okay, now what happens? I really want you to continue from here. I've given you a big clue. Now, please obey whatever is given. Find it out, please. That is not hard.
Okay. 5 plus 5x plus 12 minus 12x plus 13
Very
minus
nice.
13x
This is 12 minus 12x.
equals
This is
12x
30.
plus 5x plus 13x.
Good job. Why don't you try it out and find out? Now, just the you know that the perimeter is just equal, right? See, only thing here, when you think about this problem, right, what needs to strike you? Oh, that scale factor x applies to all the sides. That's the only thing you need to know, because they've given all the sides of one triangle. And they've also given another clue, the perimeter is the same. Did you get it, guys? I'm just going to check. I'm going to move on, please. I don't have the answer with me. Let me see. What is the answer? Please
It's
finish.
5 over 12.
5 over 12. Is that right? Is the ratio 1 by 12? I don't have the answer right now, but I can check. The ratio is, that is correct, Tanisha. Can you check Suresh again? I think there's just computation issues.
Okay.
Can you rewrite your equation? I really want you to do it correctly. Rewrite just the equation.
Okay.
Tanisha, you got this problem, right, ma? Okay. See, the first striking you is a little hard unless you do similar problems and then put it into your brain. Oh, as soon as I see this, yes, similar triangles, I can have the scale factor as x. That's the tricky part here. This I don't think is an AMC problem though. I don't think it was a past AMC problem. Can we move on? I'll see whether I can grab an AMC previous problem and give you similar triangles. I think I had one to solve as well. Let me quickly check.
Is it 1/2?
No, the ratio is not 1/2. I don't know whether this is, I want to grab an AMC problem, right? Let's see. Yeah, we can do this. No, this is also not an AMC problem. Okay, we'll do this AMC problem. Yeah, maybe this one is an AMC problem. Then we'll substitute with some other problem. Dia, what is the ratio? You're keeping too quiet. And you know what? Mitra joined. I know her connection is bad today, but Mitra, Mitra, you don't have to be on the video. I understand. You're just traveling in the flight. Go ahead. Mitra, we have just started the class and we are just doing the first problem. Okay, I did tell what we are going to do today. That's all. Keep going, ma. Are you done? Vishrank, are you done? Can I help you? If you need help immediately, please, because Tanishka is waiting. I don't want one to wait. I want to move on at the same time. So please, if you're stuck, you have to let me know. Done? This is what I have. Equal to what, guys? 12 plus 13, 25, 30 plus 20, 15x. I'm sorry. This is minus 15x. So when it goes here,
Wait, isn't it 13 minus 13x and not 3x?
I absolutely agree. 30 equal to 50x. I'm getting the ratios 3 by 5. I think Tanisha got the same. So 3 by 5. So this, then EF will be equal to 5 times 3 by 5, which is 3. 3 units long. Can I move on? Vishrank, Diya, can I move on?
Yeah, I got the same.
Okay, Vishrank and Diya.
Yeah, I get it.
Diya?
I got the
You got-
same thing.
Okay. As I said, we'll do. See, this was not a AMC problem, but yeah. But you see now, knowing similar triangles really helps. So like that, if you want me to go over permutation combination first and then move on to AMC problems, that is as well fine. Because without that, it's very difficult, I felt. That base has to be there. So that's why I'm telling you the topics which we will cover this week and next week. I'll go to I'll work on area of complex shapes. Few problems we'll do, and we'll do permutations this week. Okay, then maybe we'll go to combinations. See, another thing, divisors, factors, multiples, modulo, arithmetic is another thing, but I won't have time during the summer for all that for sure. But at least whatever we learn, we'll thoroughly learn. Geometry, a good amount of topics we covered. 3D geometry, I'm not going to touch, but I'll go to permutations first and then combinations. Go ahead. How about this, guys? The diagram shows an octagon consisting of 10 squares, 10 unit squares. That has an implication. The portion below PQ is a unit square and a triangle with a base of 5. If PQ bisects the area of the octagon, what is the ratio XQ by QY? This is an AMC problem. This is relatively easier than the previous problem. Who is going to help? AMC geometry problems are relatively easier, honestly. Permutation combinations are a little tough, meaning it can trick you a lot. Please, guys, I want you to open your mouth and think whatever you're going to say. I'm okay to listen. Because if you all keep quiet, then the class becomes so not okay. Tell me, what is it all about? What does it mean?
What does it mean by if PQ bisects the area of the octagon? Oh, okay, I got it.
You got it. See, yeah. Very nice, Resh. You became so interactive all of a sudden. You don't have to know. I just want you to be interactive. That gives a lot of momentum to the class. Vishrang, what are your thoughts? Or Diya, you have to tell me, guys. I'm going to wait to listen. Tanisha, what is your thought?
That below
Hmm.
PQ, the triangle with the base of 5 plus the unit square
Okay.
equals the area of 5.
I really like it. The base of 5 and then the unit square. Okay. From there, what I can get? What do you think? From there, what can I get?
You can try and find the height of the unit square plus QY.
Perfect. So the area of the triangle you'll get. After that,
Um, after that, we can solve for QY. So what we can do is we know the right triangle.
good.
The right triangle's area
Mm-hmm.
is equal. The right triangle's area plus 1 equals 5. So the area is 4, which means
Good. Nice. So the right triangle's area. This right triangle's area first she is finding. How she's finding. Go ahead, ma.
so the base times height has to equal 4. So half times 5 times height equals 4. So 5 of the height equals 8. The height is 8/5. And
Uh-huh.
we know that the unit square's height is 1. So
1. Good job.
8
Very nice.
fifths, take away 1 from 8/5. So 8/5 minus 1 is 3/5. So we know that QY is 3/5. And so we know that XQ is 2/5.
8/5 minus 1 is equal to QY. And XQ will be equal to 1 minus QY. So this is 3/5. This is 2/5. So what are they asking? XQ by QY will be equal to 2 by 3. Can I move on? Okay. This was an AMC problem level will be this only. Can I move on? Dear, did you get it?
Yeah.
Okay. Let's substitute with no some other problem. Let's see. This is a difficult problem. Let's see. How about this? You can think and tell me what will you do on this. Yeah, let's try this one. Did I work with you on special right triangles? We did, right? We did. Special right triangles, the basics, 45, 45, 90, 30, 60, 90, we did, right? Yep. Okay, let's go ahead. Then this is just application of all what we learned. But comparatively a little hard problem. Let's see. Tanisha, what do you think on this problem? Diya, what do you think on this problem? Okay, let me write down whatever is given. Then only we'll understand something. A, B, C. No concepts yet. Okay, whatever concepts we learned, only everything, meaning whatever we learned is being applied. This is one of the problem that gets applied. So I picked it to do it in class. AC is 8. AC is less than AB. Okay. What else is given? Point D lies on BC. Okay. BAD. BAD is BAD is equal to CAD. Okay. Let M be the midpoint. Wow. M be the midpoint. Midpoint of BC. The line passing through M is parallel to AD. Okay. Please mark everything. Intersects AB and AC in F and E respectively. F and E. E is where I don't even see. Oh, it is on this side. Oh yeah, F and D respectively. Okay. EF is root 2. See, that is a big clue for me. Is root 2, AF is 1. What can I do about this? This, okay, this I can write here if you want to. This is 1, this is root 2. Okay, what can I say? What do you think? Anybody? Anybody?
I think it shows like one of the special right triangles, like it might show a ratio.
Correct. What is that?
I don't remember. I think it's root 2, 3 root 2, and x, I think so.
Good try. But I want you to recollect. Anybody sees anything here?
It's a
Root
45, 90 triangle.
45, 45, 90 triangle. You see, because 1, 1, root 2, this is 90 degrees for sure. See, this is 1, right? This is root 2. That is your biggest clue in this. That tells that the small triangle in there, this one is a 45, 45, 90 triangle. Just because this is 45 degrees, right? This is as well 45 degrees. Then can I say this is for angle chasing really applies 45 degrees. Since this is 90, this is as well 90, right? So now what else I can do? What do you want to do about this? Now what can I do? There's something I can do. Measurements are given. Yeah, so this measurements are given in here. Is that going to be useful for us? But there's one more measurement on this big triangle. With that, what I'm going to do? I don't know. What is the length of BC they're asking? So BC is this big triangle. Okay. But before I get into that big triangle, is there anything else I can do?
I think you can the small triangle AEF is I think congruent to ABC, or not congruent, like similar.
AEF. How do you say so?
I don't know. I just took a guess.
Okay. I want you to think a little more, but you're on the right track though. Can we prove some similarity? Because there are so many triangles that are similar in here. What are the triangles that can be similar? They gave, see, we did not consider this one. We did not consider this one yet. We did not consider this one. I do understand we did not use this effectively too. Don't worry, meaning one by one only we can tackle. But Tanisha, you have any thoughts? Or Dia, you have any thoughts? You have to talk, Amma. Tanisha, I don't want you to be talking there. That's not okay with me. Go ahead. Dia, your thoughts, ma? I'm going to wait till somebody opens their mouth. Okay. Let me ask you, there are so many similar triangles in here. They have given details of this. And they have given details of this. So both I need to use. They've just given details of the big one. They've just given the details of the small one. What can I do with both? Both can be utilized in their own ways as well. I don't need to match up that and this. Tanisha, do you know, ma? You can first tell the steps. Okay. So how about this? Let's consider, let's see. How about this? This. What do you think of this and the big one?
They're similar
Why? How?
because they share a base, or
Yeah, they share this angle.
Yeah, and they share that angle.
And
So
then this is a perpendicular. Why? Because this is the main trick about the problem. In a right triangle, see, this is the midpoint of the hypotenuse. When you draw an altitude from the midpoint, it will be a perpendicular to the base.
or it's always the height.
Yeah, it is always the height. It is always the height of what?
Like say BA is the
Of the triangle, yes, of
yeah.
that triangle. Now, what can I say? Yes, they are similar, and now I know. But then I know this is 45, this is 45 as well. Both of it equal to 90. So this is 90. So basically, AA similarity I can have. Through AA similarity, I have proven that these two triangles are equal. But what does it mean? Does it mean anything to me? That does not help, right? Okay, we did not use this. What can we do with this? What can we do with this pair? Anything I can do? Because see, I also have 1 root 2. Can I do anything with that? See, that also shares the side. And again, that is also perpendicular. So they are similar triangles. So this is 1. When you think about it, right, you know this is 45. So do you see both are 45, 45, 90? Am I making sense? Both are 45, 45, 90 triangles. Does that make sense? So this is 1 root 2. Similarly, this bigger triangle is also, see, 90. We know that this is 45x. We did that, right? Let me clear out this a little bit, and then let me clear this out a little bit. See, this was 45. This was 45. This was 45. And when you look at it, these two lines are parallel, right? So this is 45. This is 45 because in the given problem, those two are equal, right? Okay, so this is 45. This is 45. This is 45. This is this is 90. This is 90. We did some angle chasing. So here it is again 45. So basically this is a 45, 45, 90. This is a 45, 45, 90. So with that in place, can we find out the sides based on whatever is given? I'm going to erase this again. We are going to just consider two triangles. 1 root 2. Is there any way for me to find out the other side? We need to find out any one of the side I want actually. One, I want this side anyway. We have two similar triangles. What else is 45, 45? This is 45. You 1 minute, guys. This is 45. This is 45. What else is 45? 45. This one, right? This is 45. This one is 45. This one is 90. What else? This is 90. So what happens? This is as well 45. Do you see the 45, 45, 90 appearing on that as well? So now what you can do, how we can measure, this is x, this is x, this was 5, right? Which was 5? Something was 5. Which was 5? 8. Oh, sorry. This is 8. Would we be able to find out? This is also 45, 45, 90. So, that being the case, do we have any side measurements given? Do we have anything given? What do you all think, guys? Did you have any thoughts on this? Is it a right triangle here? Yeah, we should be able to find this one. Is it possible to find this one? Let's see. Hmm. Did we leave off anything? 1 minute, guys. Let me see. AC is 8. Okay. Oh, the bigger triangle as well is there, right? We didn't think about the bigger triangle. Okay. The bigger triangle in this can be used. Okay. The bigger triangle. This one is also 45, 45, 90. But that's not helping me. Okay, let's see this one.
I don't think that angle ACB can be 45 degrees
Which one,
because
ma?
angle ACB, I don't think it can be 45 degrees because that would mean that angle ABC would also have to be 45 degrees, and we know that AC is smaller than AB. So,
But this is 45, right, ma? This is 45, right, ma?
yes, but
This is a triangle, right?
yes.
This
But
is
I don't, it's not, we know
mm,
that angle BAC is 90 degrees.
this need not be 90, right?
Yeah, no, it
This
doesn't.
need not be 90.
Yeah, because if angle ACB was 45 degrees, then angle,
I see what you're saying. Then
yeah,
8, then we'll be able to find it easily, you're saying, right?
yeah,
Yeah,
but
this is
AC is
not
smaller
90.
than
That
AB,
makes sense.
so
That
that's
makes
not
sense.
possible.
So where are we making a mistake? Let me see. Hmm. See, this one should give inputs for us. 1 root 2 should really give inputs for us for this one. Let's see. This is, yeah. Okay. See, this one bisects the base. This one bisects the base, right? Because this is the midpoint, right? That's how I have solved. So this one from M, when it comes down, this is a total of 8. So can I take this as 4, 4? If I take this as 4, then I can easily find the height. This one becomes 5. So that is a 45, 45, 90 triangle, right? 45, 45, 90 triangle, right? So if that is a 5, this is a 5 root 2, right? This is also a 5, right? Now from there, this is a right triangle, right? 4, 5. So what is that? 16 plus 25, which is square root of 41, square root of 41. So both will add up to square root of 41. Does that make sense? Here the trick is only this. It gets down from the, it gets down in a right triangle. The midpoint when it joins, this is an altitude and bisects the base. So here, this can be split into 4 and 4. Now, we know this is 1 root 2. Then you can compare this. Here, since this was 4, we ended up choosing this as 5. Now, what happened? I'm losing track. So if this is 5, this is as well 5 because it is again a 45, 45, 90 triangle. 5, 5, 5 root 2 is here. Okay, but we don't need all those. Only thing we already know this part is 4, this part is 5. Finish up the right triangle and then duplicate it here. Square root of 41, square root of 41, 2 square root of 41. Make sense? Can I move on? Okay, let's do one more at least. I want to do. Okay, we'll do. Let's see. I want to name say problem. We did something outside, right? So I want this. Let's see this one. This one is relatively easy. See, when we solve AMC8 problem, a non-AMC8 problem, that way I am thinking one will be easy, one will be hard on you. So this one, you let me know what you guys think. I'll help. Last I solved, right? That was a difficult one. That's why I solved. So how about this? Rectangle DEFA is a 3 by 4. Okay. I'll write out whatever is required. 3 by 4. Let's see. This is 3 by 4. DC equal to CB. DC equal to C. Okay, the area of batwing shaded area. Oh, we need this area. Okay. What we can do? What do you all think we can do? What do you all think we can do? Guys, I really want to understand. Don't keep on doing. We are all in a group, solve helping out each other. Let's keep it that way. Then only ideas will flow. What can I do?
I think we can take the shaded area
Mm.
area and then subtract it by the total area.
Nice. Shaded area will be equal to the rectangle area. I also see that minus.
No, it's the other way around. The non-shaded area equals rectangle area subtracted by shaded area.
But you need to find the shaded area, right?
Oh, okay.
Makes sense. So why don't I put it as triangle 1, triangle 2, triangle 3, triangle 4. Let me subtract all of them. Triangle 1 plus 2 plus 3 plus 4. Triangle 2, triangle 3, triangle 4. Okay. But my main problem is triangle 1 and 3 seems easy. 2 and 4. What do you think about 2 and 4? 1 and 3 seems very easy because you all know the area of those triangles. It's not hard at all and it's the same as well, right? 2, 2. Let me put that down. 2, 2. That's because you see everything is given. It's not a hard one at all. Triangle 1 and 3 I have. What do you think about 2 and 4? Guys, tell me, guys.
They're similar
Why?
because they're both isosceles triangles with.
How do we know? We don't know.
They
I see. Tanisha, I agree with you, but I want you to defend yourself.
Yeah, because CB is 1 and we know EF is 3. They have to be isosceles because the bat wings are congruent
How do we know?
because they both meet at one point from.
So, no.
it says that DA is split into 3 equal parts because it's 1, 1, and 1. And then they all should equal EF, which is 3.
EF, which is 3. Correct.
They also share an angle, vertical angles.
True. I really like it, Sresht. Yes, this is one of the angles that can prove similarity, but there's one more concept that proves their similarity.
Also,
This is the biggest clue. Rectangle DEFA means what? This is parallel to this. As a result, consider this as a transversal. That's what I'm seeing. This is equal to this. What similarity is that?
Angle.
Angle similarity. Triangle 1 is similar to triangle 4.
Triangle
Okay.
2.
Oh, triangle 2, amma. Triangle 4, right? Sorry, yeah. Triangle 2 is similar to triangle 4. Correct, sorry. Now what? We know. We already know. One of it is there. So what is the ratio?
It's 3 to 1.
3
Yeah.
to 1. Yeah, exactly. So the same thing on the height as well I can do. You see? So what this should be?
3 and triangle
Yep.
2 should be
Yep, yep,
1.
yep, 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 yep. Now you know the area, right? Let me see. For triangle 2, it is half times 1 times 1 half. For triangle 4, it is half times 3 times 3, 9 by 2, right? Let me put it down here. So I'm going to combine this 10 by 2 plus 2 plus 2. 5, 6, 7, 8, 9. Okay, but we know that this is 9. Triangle area is 3 times 4, right? 12. So shaded area is 12 minus 9, 3 units. Makes sense? 3 units square. Make sense? Okay. Shall I move on? Okay. We'll get off this, I feel. Okay. How many more problems did I plan? Because if I keep doing it won't work. Hold on. Give me 1 minute what I
Are we gonna do permutations next class or this?
Illa, I want to do this class. Okay, please let me take 10 minutes. Okay, see, I really want you to try this. This is an AMC8 problem. This is on area. I said I'll do some problems on areas as well, right? This one I want you to try. It's not a hard one, please, guys. This is on area. This is an AMC8 problem. So whoever has tried AMC8 problem should be able to deal with this and should strike. The idea should strike at least. It's not a hard one. But seems very hard when you look at it, but geometry problems, you can really touch them. You can really touch based on what we have studied. Do you need help? Diya or Tanisha or Vishrank or Sresh, if you have an idea, please blurt it out so that it helps others as well.
The sides of both the rectangles are just the area squared.
Yeah. So this is root 32, root 32, root 32, root 32. Then what? This
Then
is
we
root
can
8. Then what?
then we can use the side length of
What is a
we
regular
can use
pentagon?
F.
Yeah, go ahead. Equiangular means what? It's regular. Regular means sides are
Yeah.
all equal, right?
Yeah.
So what happens?
So we can use the sides to like make the area, like we can use the sides to find the area.
Okay, wonderful. I'm really happy you're all coming with this. Okay, this you all understood root 32. This is root 18. But how to find the area of this triangle? Let me erase everything off, guys. It's so hard. How do I find the area of the triangle?
I think we can find KC and then use the semi-perimeter rule or the formula.
Semi-perimeter. Okay, I really like that idea as well. Semi-perimeter, you need to know this one, right? I don't know this
Yeah.
one, right?
Yeah.
There's something else. See, both your angle chasing and whatever tricks you have for areas is really helpful. What can you tell about this triangle? There's some special property about this triangle. What can I say about it? Dia, do you think you can think about it? Suresh, you're able to say something about it? I gave you a clue.
No.
No, not really. Okay, no problem. Yama, tell me. Equilateral, which is equilateral? This is equilateral. Okay. Immediately mark as soon as you read, right? In the paper, in your question paper, mark, then you'll have more answers. So I gave you 90, I gave you 60. What else I can talk about? What else I can say? Tanisha, any thoughts, ma?
No.
What is this? Hexagon is equiangular means what?
It's regular.
regular, equiangular. That means regular and polygon angles we did
All of
discuss.
the angles are same.
All the angles are same. And what is it?
60.
N minus 2 times 180, right?
Oh yeah.
Divide by?
Divide by the number of sides.
Exactly. So each of that is 120. So what happens? What is this? It is a
It's a circle and it's 360 and we can find that.
correct. 360 take away 60, 300 take away 120. You have
280.
No, it's
180.
180.
180.
Sorry, yeah,
180 take away 90. What is remaining?
90
90. So this is your height. This is your base.
base.
Simple. So you already have both. You can find the area. Can I move on? I don't think we need to compute, guys. Okay, you all know how to multiply, right? I am thinking you know how to multiply these two. Do you know how to multiply radicals? All
Yeah.
of you? How about you, Tanisha, Dia? You know how to multiply these radicals? 3 root 2, this is 4 root 2, I think, right? Is it 4 root 2? Yeah. Half, so this goes. So 6. This is 6 times 2. I'm getting 12. Can I move on? Okay. Okay, that's all I wanted to do on that. Okay, I have more, but I don't think I'll have time on this. Okay, let's touch permutation, guys. Maybe one more on the area and then I'll touch permutation. How about this? This is also an AMC problem. See, when there is an area problem, try to get it done, is my honest request to you. Meaning, when there is an area problem that you're coming across, right? Meaning, if there is an area problem in AMC 8, definitely try doing it. It should be easier than rest of the stuff. Then, whatever related to special right triangles, similar triangles, anything works. Okay, what is this? This one you can solve by yourself. They have given it's a parallelogram. See, half of the problem should be easy, half of it should be hard. Use the measurement. What is it? Yeah, I think it's easy. BCD is rectangle. EFGH is a parallelogram. Okay. See, basically, if it's a many things you can find out.
Since D is perpendicular to HE and GF, would it be right angles?
Yes, absolutely. So you know what? You have to consider that this is the base of the parallelogram. Since they have given that this is the base of the parallelogram. Parallelogram's area of the parallelogram, right? Yeah.
The base is 5 of the parallelogram.
Correct. Base is 5 of the parallelogram, correct, and height. But what is the area of the parallelogram? That is easy to detect as well.
Yeah.
How? How?
You would have to find the hypotenuse of triangle HDG.
Correct.
Would be 25 plus
36, 25.
that would be 11 161 square root of 61, and then you just have to multiply 5 times square root of
Did
60.
we do it correctly? Did we do it correctly? Yeah.
Yeah.
Yeah. Okay. So now area of the parallelogram is what?
5 root 61.
No. Area of the parallelogram is base times height, right? That we already did. But how to find the area of the parallelogram? We don't need to find this, I feel. What is the use of finding it? I don't see any use. Okay, Sresht, here I have a thought for you. Meaning, in a parallelogram, right? Please remember the area is not this times this. The area, if you consider these two, meaning if you consider these two as the basis, right? This is the gap in the concept. These two as the base, right? Perpendicular between them is the height. Okay, and similarly, if you consider these two as the bases, right? This is not the height. a perpendicular drawn to both of them. Like this it will be. That will be your height. Make sense?
Yeah.
So here, if this is the height of the parallelogram, you already took this as the base, which is great. That is area of the parallelogram. You need to find out the height. That's the original question. But is there any way to find out the area of the parallelogram?
Yeah.
Hmm.
We could take EF and HG as the bases and 5 as the height.
No.
No, no, no.
Because if you take like that, right, nobody said that this is 90 degrees.
Yeah.
And it is not as well. So see guys. Okay. Dia or Tanisha, you let me know, or Vishrank let me know how to find the area of the rectangle, area of the, I'm sorry, I gave you the clue. How to find the area of the parallelogram? One side is done.
Oh, okay, okay.
Yes, tell me.
You have to find the triangles area and then subtract it from the
Good
rectangle.
job. That's it. All are 90 degrees. That's why I'm saying you mark, then you'll clearly know. You'll easily find the area of this. What is that?
5,
15.
15, yeah.
Yeah, so this one is 6.
6.
This one is 15. This one is 6. The total area is what?
42.
10 times 8, right?
Yeah.
80 minus
42.
30, 42, correct. 42. So this is 8, this is 7, 38 will be
Yeah.
equal to 5 times height. Height will be equal to 38 by 5. Any questions?
No.
That is
Oh,
D.
I got it.
Okay. Let's see. What other things? Okay. So area you will pretty much manage is what I feel now. Permutation, I need to have some concepts, right? Okay. Have you heard of permutations? I really want to know your background, each of your background. Permutations, have you heard of it? You've heard
Yeah,
of
I've
it?
heard of permutations before.
Okay.
Like,
Now let's
I know
say,
a little bit.
okay. How about Sresh? Do you have heard of it?
Yeah, yeah. I
You have heard of this?
bit of it, yeah.
You know the formula for this?
No, no. I've done like very simple questions, not
Okay.
like the formula ones.
Okay. Tanisha, how about you?
Yeah, I know permutation combination.
You know what is the formula for NPR and all? Do you know how to n permute R?
Yeah, it's n factorial over n minus r factorial.
Okay. Okay. Now, another question to Vishrank and Shrestha. I'm not asking Dia because I know. Shrestha and Vishrank, do you know what are factorials?
Yeah, yeah, I know
Yeah,
fact.
I know a
Okay,
factorial.
good. Okay, now, okay, what is this permute? Permute, let's say you're 5 in class today, right? You want to stand in a line. In how many ways can I make you stand in a line?
It's the factorial of how many people there are.
So
Yep,
factorial 5.
yep. So basically, why is that the case?
There are 120 ways.
Yeah, so you did it as 5 factorial, but why, Emma?
Because 5 people can go in the first spot, 4 people can go in the second, 3 in the
You
next,
already
2
took
in the
it.
next, and 1 in the next.
Nice.
Yeah.
So so this is basically 5 factorial. That is where permutation comes into picture. Meaning here, let's say Sresh stands here, Vishrang stands here. The order in which this can be Vishrang, this can be Sresh. This is considered one way, this is considered one way. Both of this are not the same. So when the order is important, we go ahead with what is called permutation. Meaning permutation tells when the order is important. Permutation is the concept we get into to find out the number of ways something can be ordered. Suppose so here I don't want to go to combinations yet. Okay, so let's see. Okay, let me ask you a couple of questions. Okay, how many 3-digit even 3-digit even numbers are there? Can you work this out? See, once I have to understand where we are on this. I'll take another 2-3 minutes, okay? We'll do some problems and then move on. Circular, I want to say, let's see. Subsets, do you all know? Set and how many number of subsets from the set?
No.
Okay. Diya, I know. Tanisha? Sets. What I'm asking is, let's say I have a set 1, 2, 3. How many subsets can be made from this? Do you know that?
I think 3.
Not really, ma. One is null, one is 1, 2, 3. Then you have 1,
yes.
2, 1, 2, 1, 3, 1.
Yeah, I know. I kind of know sub and subsets.
Subsets. But do you know how to find the number of subsets from this set?
You could do that. Looks like I'll calculate it. Let me see.
Yeah. Sure. Good try. Not a problem, but I just want to know. So there are a couple of problems that I wanted to cover for permutations using subsets. I can do it next week as well, but let's do this one
There'd
first.
be like 6 subsets, I think.
6 or 8, Amma. I think it's
Yeah,
8. 2 power of
8.
I think it's 8.
I thought there was 7.
No, I think there are 8.
Those-
Let me see. Because see, by formula I'm able to calculate. So let's see. 1, 2, 1, 3. 1, 2, 1, 3, and then 1, 2, 3, and then 1, 2, 3. So there
Oh,
are 8, right?
Is 1, 2, 3 a subset?
Yeah, it is a subset of that set. Yes.
And then what? So then there's 7.
Null,
oh, yeah.
empty subset.
Okay.
Okay. So this is what a subset in sets. Okay. And then the thing why I am bringing this up is unless you know set and subset, right? You cannot solve some permutation or combination problem based out of set and subset as well. So yeah, the basic you need to know. But one thing, guys, don't make it that complicated. Now you know set and subset. I'll tell you the formula. If you have suppose it's an n number of numbers in the set, right? 2 power of n will be the number of subsets you can frame. This includes the null subset. Okay. If you exclude the null subset, it's 2 power of n minus 1. We call, if you include the null subset, we call that as proper subsets. Okay. Proper subsets means it will include the null. That's all. That's the base thing that you need to know. It's just some theory facts and some patterns and some formulas. We'll do that later. Can you do this one quick, ma? We'll do 1 or 2 more problems and then I'll let you go. Yes, ma. Please, 3 minutes. Wait. How many 3-digit even numbers are there? Did you get it? Guys, if... Really? Okay, let me count. I don't know. I don't know. How did you get, Tanisha?
I got 900. Or no, yeah.
900 I didn't get 900 either. I don't know. Let's see.
I think my answer's wrong. I'm not.
That's okay. See, we'll do it together. That's what I'm saying. It's okay. Meaning we all help out each other and get it. That's the way we have to look at the class. 3-digit even numbers. Now, see. Okay. Yes, Mitra. You want to say something? Yes, I know. If you have an answer, you send it to me. I can explain. What am I? That is correct. Mitra. You made a mistake on 1, the middle digit. That's right. All the other 2 are right, Mitra. But the middle digit has more. Okay, I'll tell you. See here, how many 3-digit even numbers are there? So what can fill in the last digit? Even numbers means it can be 0, 2, 4, 6, 8. So 5 options, 5 choices. Then what other numbers can go here? Meaning this one cannot start with a 0. Then it becomes a 2-digit number. So it has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, Mitra, that's right. So, so this is 9 combinations. Here, how many digits can go?
10.
10. That's it. So 10 times 9 times 5 is 90 times 5, 450. Make sense? Okay. We just need to do some basic work and then we have to move on. I feel with permutations, let us see. I don't know. Okay, we can do that as well. Let's see. Give me 1 minute. I want to give you one more problem. I'll let you go. Okay, I don't want to do too many as well. So let's postpone the harder ones for next week. These are all hard ones. Whatever I have are hard ones. Hold on. I want you to do 1 or 2 simple problems and then go. Okay, how about this? This is a good one. Okay, similar to what we did. That was just from my brain I gave. Let's see this one. How many 4-digit numbers exist such that the first digit is odd and the other 3 digits are even and are all distinct? That's a good one actually. See, silly mistakes are very prone, meaning you will be very prone to silly mistakes. Solving several problems and permutations gets you out of silly mistakes. Diya, good job on the last one. Tanisha, I saw your answer. Go ahead. It's an easy one as well. Don't make the silly mistakes though. 4-digit numbers, huh? First digit is odd, okay. Other 3 digits are even and distinct. We'll do some hard permutation problem and then we'll go to combinations next week. I will also try to insert some 3D problems. 3D, okay. I don't know who said they have done. Have you all memorized formulas or do you know 3D based on base area times height for volume? How do you do? You go with formula, meaning, guys, I really want to have an understanding of how you do in school. What do you do? Do you do the based on formulas for 3D?
I'm going to 7th grade, so I'm not really doing geometry.
No problem. Yeah. In 7th, you will have 3D work. You're going into it. Okay, got it. Tanisha, how about you?
I never covered 3D in school because I skipped the 2 math levels in which we do 3D.
Oh,
So
I
never
see.
covered it in school, but I know the formulas.
You know, you go by formulas. Okay. Vishrank, you?
I know like the formulas for like some 3D, but not like
Everything.
lot.
Okay. Diya, I know you, ma. I'm not going to ask. Mitra, you don't have to answer. Yeah, ma?
Is the answer 2520?
2520. I don't know. I have to check. Okay. What did the others get? Mitra has an answer. Let me check. I know only some formulas. Okay, 3D. Okay, let me try to insert 3D next week. Okay, when we go to harder
I got
permutation.
2520 as well.
Nice. Why don't we check? Honestly, I don't know the answer. Let's check. 4-digit. With this, we'll go. 4-digit numbers exist as if the first digit is odd. First digit is odd. This is 5. And the other 3 digits are even and distinct. Means even and distinct, it can be 5, 4, 3. Yeah. So 2500. What did you all get?
Oh, no, sorry, I made a mistake.
Okay, what are the other answers you got? Both of you got 2520?
Yeah.
Wait, do they all need to be odd?
No,
No,
how many
they
4
all
digits?
have
Wait,
to
the
be.
first digit is odd. The other 3 digits are even and all. Yeah, I'm getting only this, right? Why?
Because I did 5 times 9 times 8 times 7.
Yeah, that's what I did too.
I see. You did 5 times?
9 times 8 times
Times
7.
7, yeah.
You know what? They've given, right? And other 3 digits are even. So what can go here? Only 2, 4, 6,
Oh,
8.
okay. I see.
Okay, 5. 1 is taken here. So 4, 3. Make sense?
Yeah.
Yeah, see this.
Yeah.
You all got the concept of permutation, but the problem is you have to solve a lot more problems to avoid the silly mistakes. That's all. Okay, it is prone to silly mistakes. Okay, any questions? Okay, so we'll stop here. I'll give you work on permutations, more nice similar triangle problem, not the easy ones that we dealt with last week per school level. This is going to be a competitive math level similar triangles, and I'll give you on permutations, okay? But only I can give you very, very basic level of permutation. Combinations we'll do next week, and permutation harder problems. If possible, I'll insert 3D geometry. Okay, guys? See you all next week, guys. Bye, ma.
Okay.
Thank you. My mom wants to talk with you.
Sure, ma.
Mama.